Okay, good morning, 2020. My name is Kunda Mlenga. Today I want to present something to you coming from physics. In particular, we'll be looking at magnetism. And unfortunately enough, we started this topic some time back. So today we won't be looking at the introductory point of it. In short, we'll just have a continuation of my last presentation. So today we'll be looking at, like I said, magnetism. That is a method of magnetism, and then we'll be looking at how to magnetize. Magnetization or a magnetic material. Magnetic material. In particular, we'll be looking at how to magnetize steel. Now, we looked at the first method that is involved, and actually there are two methods involved. The first method is called stroking. Now this stroking can be a single stroking or we can have double stroking. That's the first method that we looked at, and I never much on it. I'm not very far to this particular method. Then the other method is called electromagnet. Magnet. So that is what we'll be looking at today. We'll be looking at how to make a magnet using the method which is called electromagnet. Now, electromagnet is a method where we use electricity. This method of making a magnet depends entirely on the use of electricity. So let's look at how we can make a magnet using electricity. So this method is called an electrical method. Electrical method. Now, it being electrical method which involves electricity, that means the electricity has got a vital role to play in this method. Now, what are the things that we need to have? So I will say materials. The materials that you need to have, one, you need to have source of electricity. Now, it's not just any source of electricity that you find that can be used. In this method, we use what we call DC. What does DC stands for? Stands for direct current. Now, where can you find this direct current? The current that flows in the wires in our homes, that is not the one I'm talking about. That is an AC alternating current. Why? Because it changes the frequency in the wires, changes the current changes the direction 50 times per second. So because of that, it changes directions. That's what is called AC. When you have a 2-pin plug, the order in which the 2-pin plug goes on the power socket does not matter. Do it like that, or even when you flip, no electrical appliance can get damaged. Why? Because the current flows in opposite in either directions 50 times per second. But the one that we're talking about that we have to use is the one that has a particular direction, like the current in the batteries, these batteries that we find now. In our phones, these batteries that we find in cars, the polarities, the positive and negative, are very important. Once you swap them, the electric appliance may get damaged. Why? Because the current does not change the direction. So that's the type of current that we need to have. So one, you're saying that we need to have a source of electricity, and the one that we need to have is DC. Then the other one is definitely we need to have a magnetic material. But this magnetic material, we call it a hard magnetic material. And in our today's presentation, we'll be looking into how we make a steel, which is a very good example of a hard magnetic material. How can you make steel a magnet? Okay. Then the other thing is this electricity must be connected to what we call solenoid. So you need to have what we call solenoid. Now, what is a solenoid? A solenoid, and I'm going to explain much about that. You need to have copper wires that are insulated, wrapped around up in a cylindrical way through which the steel must be slotted in, but I'm going to explain on how that thing is done. So those are the things that you need to have when you are looking at when you want to make steel a permanent magnet. Steel is an example of a hard magnetic material. So, what are we seeing? This method, once you use this method, the type of a magnet that you're going to make is a permanent magnet. What's a permanent magnet? These are the magnets that you find in radios, the magnets that you find in speakers, these magnets that you find in many electrical appliances, especially in speakers. Okay. So now, how is this method done? How is it done? How can you make steel a strong or a permanent magnet? The question that I need to do is, so method or steps or our common procedures. So you need to have a solenoid setup. So it says set up a solenoid as below. So I'm trying to show you now how we can do this. So a solenoid, I say, is a cylindrical wound of insulated copper wires. So we're going to have a cylindrical arrangement. So that means we're going to have this is a wire. Or maybe the first thing here that I can include is a connecting wire. Connecting wire must also be there. So how is it done? We're going to have this is our connecting wire that is wound up in that way. So these ones here are insulated copper wires. Insulated copper wires. Okay. So you're going to can have an open switch here, and this is a power supply. Okay. And we know very well that the longest terminal of the power supply, which is called the anode or the positive, and the shortest terminal on the circuit like that, it's called the cathode, which is the negative terminal. So this setup here. This setup here is what we call solenoid. This arrangement here is what we call a solenoid. This one here is a connecting wire. That is a connecting wire. This is an option. This is our DC supply or source of power. Okay, so according to the materials that we have, I have demonstrated where the source of power is coming from. This is our source. So I will be reminded that the power using here is DC. Okay, what else? I've also demonstrated where you have to put the solenoid. Now, what do you do? So that hard magnetic material, which is a steel, you are going to slot it in like now the second step. So you have to have this magnetic material slotted inside of the solenoid. So you need to have the magnetic material being slotted inside of hoop. So I'm going to say this is steel. So we're going to have the steel now being slotted inside of hoop. Once you slot it inside, then you close the switch. Now, once you close the switch, then electricity is going to flow in that direction because this is a positive terminal, so current is going to flow in that direction. So current will flow in that direction because the flow of current is very vital, which is going to help us in determining whether this is a terminal should also have the negative terminal. The flow of current is very vital because it is going to show us, or it's going to help us in determining which one will be the positive terminal and which one will be. So once this happens, once you have that setup done, with the current and the power switch closed, of course, you have to wait for some minutes, some good minutes, and then you find that even if you remove this, you remove this magnet, if you remove this setup, you find that this will still remain a magnet. Now, what happens is that when this current flows through the solenoid, there is, okay, I'm not going to explain much about the feelings and the like. Magnetism, so come and explain it later. But all in all, just know that when you have the steel plugged in with the switch closed, after some time, this will be made a permanent magnet. How that is done, I'm going to explain it in the second presentation. Okay, so that is how we can make steel a permanent magnet. It's different from stroking. Stroking, I'll explain a bit later earlier, so I'm not going back to that. Now, how do you determine polarity? How to determine the poles which we call polarity. Polarity. How do you determine it? What we call right. So the method that we use is called right hand grip rule. So that is a method that we use to determine which one will be the North Pole and which one will be the South Pole. Because initially it was just a magnetic material like that. We do not know which one will be the North Pole and which one will be the South Pole. So what we use is the right hand grip rule. Now, if you look at my right hand, this has got a specific name, which is called a thumb. Okay, now there is what we call first and second when you are dealing with the Fleming's right hand rule. But on the right hand grip rule or grip method, we just consider the thumb and the rest of the fingers. Only the thumb and the rest of the fingers. So what happens is that you need to have the thumb. Now, the direction of the thumb points to the direction will be, and the rest of the fingers, so rest of fingers, they demonstrate the flow of current. How is that done? Like I said, if you get to have this, the anode, the positive terminal, and the negative terminal, current will be flowing in that direction. Goes behind, comes out, up, behind, out, up. So we're going to have like that, where these fingers must show or must point to the flow of current, and then the thumb will point to the side where the North Pole of the magnet will be. Okay, so if we get to have our thumb, our fingers showing the direction of current, and then this side will be our North Pole of the magnet. So what happens if this was not the negative and this gets to the positive? We'll see the current now going like that. We'll see now the current going downward like that. So we would have gripped our right finger like this so that this gets to be the North Pole. But regardless to what we have here, because regardless of what we have here, this is a positive side, indicating that the side through which current will be coming from. That is where, when we put our grip, our right hand grip method, we will have the North Pole on this side, and this side will be our South Pole. So that's how you can determine this is how we can determine which one the North Pole and which one the South Pole. So the method is the thumb must point to the side where the North Pole is, while the rest of the fingers should indicate the solenoid. If this was to be the solenoid, having current moving in an upward direction like that, we would have put the fingers like this so that this points to the side where the North Pole is. Okay, now one thing you need to take note of is that this is a method that makes stronger and permanent magnet. This is a method that is to make stronger and permanent magnet. Now, of course, we are saying stronger or permanent magnet. Definitely, there must be certain things that we have to do to increase the strength of the magnet. There are certain things that you need to do in order to increase the strength of the magnet. So I'm going to look at three things. So I'll say how to increase the strength of the magnet. Strength. Now, how to increase the strength of the magnet? There are three things that we have to consider. One, the source of power. You have to increase the source of power. So one, you make sure that you increase the source of power. If at first you were using 6 volts, the moment you have an upward increment in terms of the power supply from 6 to 8, you find that the magnet that you're going to produce at the end of the day will be a bit stronger. Increase the power supply. Number of turns in the solenoids. The number of turns in the solenoids. Once you increase the number of turns in the solenoids, you are also increasing the strength of the magnet that will be produced at the end of the day. The number of turns in the solenoid. There are 3. Now, the material that you also use when you're making the solenoid matters. The material that you are using when you are the material that you're using when you're making the solenoid also matters. So don't say the material. I can call it material type of solenoid. In most cases, what they use is the material of using not the solenoid, but the core, the inside of the solenoid. In most cases, what they use here is soft iron. Now, the wires that are outside the solenoid, those wires are not talking about. The cylindrical arrangement, then outside you put the wires. That's soft iron. Why? It is because iron is easier to magnetize and demagnetize. Demagnetize. So these are the things. One, increase the power supply, and of course the power is supposed to be DC. Then 2, the number of turns matters. Then the other thing is the type of the core that you use, and in most cases, if not all times, they use soft iron core, and because iron is easy to magnetize and easy to magnetize. Now, in case you used a steel, a hard magnetic material which was reserved for something. No, that which I used for making a magnet, I had it reserved for other vital duties. So now, what can you do to make sure that you remove the magnetic power from it? That's what we call demagnetization. So how can you demagnetize? In case you have used the magnetic material, which was reserved for some important functions. Now, Mom says, no, that which you have used are reserved for something better. So, how can you do, what can you do to remove the magnetic material from it? So, that's what we call demagnetization. Demagnetization of magnet. Now, demagnetization is a process of making a magnet lose, because if this is what we had made as a magnet at the end of the day, it should have the capabilities, it should have the capacities, it should have abilities to attract magnetic materials towards itself. Now, what can we do to remove the magnetic powers that it has? What can you do to remove to enable it to lose its magnetic properties? So there are 3 or 4 things that we have to do. Number 1, just heat it. If this is a magnetic material that you subject it to high temperatures. When subject to high temperatures, you find that it is going to lose its magnetic properties. If this was to be pure physics, I was going to demonstrate what happens inside the magnetic material. What happens to micro particles that we call dipoles? What happens to the dipoles inside of the magnetic material when it becomes a magnet? But I'm not going to go that way because this is just science. We're not doing pure physics. So what happens? We just heat it. Now, when subjected to high temperature, this magnet will lose its power. What other things are you supposed to do? Need to heat, you just need to hammer it. If this is the magnet, put it on a hard thing, get a hammer, start hammering it. Because we know from the word go that metals are sonorous, metals are malleable, metals are ductile. Now, the malleability, the ductility of metals depends on the type of the metal you're talking about. This is the steel that we're talking about, and carbon combined. And actually, steel is an alloy according to the chemistry world. Now, the malleability and the ductility of steel is different from that of a pure element. So once you hammer, at the end of the day, you find that it will be unable to pick magnetic material. Okay, the third but not the least is change the current type. Remember, we said when you're making magnets, the type of current that we have to use is what? Direct current. But in our case, the one that we have to use is AC. We have to use alternating current. So the same arrangement that we got. The same arrangement that we got is what you can have. Again, if you want now you have to use of the methods, 3 of them. No, if you want just use one, use this one or use this one. Now, if by any means you're trying to use this, okay, I don't know if you can see the handwriting. So I'm saying change the current, change the current type. Instead of using the DC, the one that we had at first, we have to use AC. Now, what is AC? AC stands for alternating current. Now, it says, if you want to use the alternating current, what are you supposed to do? You need to have the same setup. You need to have the solenoid. You need to have the solenoid here. You need to have the solenoid. Okay. You need to have the solenoid. Now, this solenoid here, open switch. Okay, this is a power supply, open switch. Now, if we say current is moving in that direction, if say current is moving in that direction, instead of having OC, you're gonna use now, instead of having DC, you're gonna use alternating current, which is able to change the direction 50 times per second. By so doing, it is disturbing the arrangement of magnetic dipoles inside magnetic material. So what happens is that this switch is open while the magnet is inside. The moment you close the switch, then you withdraw. You withdraw. You withdraw the magnet. So that's what it is once the switch is closed, then you withdraw that magnet that you have made. Now you have to do this process several. You have to repeat this process for several times. At the end of the day, you find that this magnetic material and it will go back to its initial position. So that's what we're going to end for today's presentation. We're looking at magnetism. What is magnetism? That was dealt with later. The introduction to magnets was done later. Today's presentation started on how to make a magnetic material becoming a magnet. Now, I said there are two methods. There's what we call stroking. Stroking can be double stroking or single stroking. I presented that later. Today, I just started from how we can use a magnetic material by using the method of electromagnet. Now, because this involves electricity, that's where the name came, electro, coming from electricity, electromagnetic method. And I demonstrated how that is done. Then from there, I went as far as how can you increase the strength of the magnet. If this is a magnet that you had made, then it is unable to pick several several magnetic materials. How can you increase its strength so that it is able to pick more than it was picking at first? And then later, I have looked at the methods that you can use to remove the magnetic material that you had imposed in the magnet before it became one. All right, so that's where we end for today's presentation. I wish you a good festival season. Be good. Let Christ guide you as you celebrate the